Okay, hooligans, welcome back. So we added our animations, and then we went ahead and we set up the variables, and we copied and pasted some code from Blueprint UE. And we did all this in the animation blueprint, where, let's open this up. Let's take a look over here on the left. You see we have our 2 reference variables and our 4 essential movement variables. We're going to go ahead and create our first state machine. But first, what I'll do is I want to kind of step you through what's going on in the code that you cut and pasted from Blueprint UE. So let's, hopefully you can see this. I'm going to try and blow it up the best I can here. And I'll kind of go through this because it'll set up sort of what we're going to do next. And in this video, we're going to set up the Locomotion state machine. But what we've done is we've gone ahead and created this code in our event. And the first thing that we did in our event graph, you see up here, and by the way, this code is all from the third-person sample that comes with Blueprint, with Unreal. And so I'm using the same techniques they would use to create this movement and the animation, tweaked a little bit. But you find this same code if you go ahead and do a starter project with the third-person animations or the third-person game, and you'll get all this same code. But let's walk through it real quick. So the first part of this is on its own, and it's setting reference to the character. So we when the blueprint's initialized, we get owning character, and we set that to our character. So remember, we created this character variable, which is an object type character. So how does it know it's our Hooli? Well, when the blueprint initializes, we get the owning character, which is the character that's in that animation instance that's associated with it. And we cast it to character. And then we target the character movement, and we set our character movement variable. So what all this does up here is it really sets up our character and our character movement into these reference variables that we have so that we can use them later. Now, the second thing that happens is this is the update event, it's called. And basically what we're calling to see if our character is valid. So really, if valid, we'll get the character. And then we'll do a couple of things, and these are pretty straightforward. So one thing we'll do is from the movement component, we'll get that velocity, and we'll set that to our velocity variable, right? So remember, we have our velocity variable here. We'll get the length of that. So which that means is we will want to set our ground speed based on the length of the velocity variable. So the vector length xy moving across. In this case, we're just doing x, so we're moving across the way. So it returns that vector, and we set our ground speed. So in this one, we're setting the ground speed variable by getting the movement component and the velocity of that. The second thing, we're also getting the movement component, and we're looking at acceleration here. And what we want to do here is, this is a way for us to kind of, you can read the notes. It should only move if there's above a small threshold, so that the animations don't kick in until, and in this case, greater than 3. And so really what this does is it gets the acceleration, which is to say, if you read this, returns vector A not equal B. So that means that there is a difference, and they do see acceleration happening. We do see acceleration happening, and we set get our ground speed variable greater. If it's greater than 3, then we set should move to true. I'm not sure if I'm explaining that great, but the goal of this whole set of code right here is to get set should move set to true if the ground speed is greater than 3. Otherwise, should move is false, and we'll take a look at that in a few minutes as to how that's impacted. So get the acceleration. Is there acceleration happening? Cool. Is it greater than 3? Cool. Then should move would be set to true. The third block here is about falling. And so in this case, the movement component is falling. So this returns true if it's currently falling. So not flying in a non-fluid volume or not on the ground. And if that's the case, is falling would be set to true. Otherwise, it's false. And the reason we want those is, we'll see in a few minutes, the should move. We want to know when we should kick a certain animation, whether it's the walk run animation. And it's falling, we want to know when we jump off something, if our character's falling, we have a cool animation for our Hooli during the falling stage. So in short, you can dive more into this. I'll put some links in the description on some of this, but really we're trying to initialize our two reference variables to our character and the character's movement, and we're trying to, if our character is valid, we're going to check we're going to set our variables, our velocity, our ground speed, and our is falling variables, and should move. So hopefully that makes sense. Let's go in then to our anim graph, and let's go ahead and set up our first state machine called Locomotion. So if I open up and double click over here on the left, anim graph. So again, we were in event graph. So event graph is where you put code for events for the blueprint, and anim graph is also a blueprint, or there's nodes in this particular blueprint. The whole thing is the animation blueprint, and the output pose is eventually what's going to execute. And right now, if you see a note, it's the result was visible but ignored. There's nothing coming into this, and we're going to change that. We're going to add a few things. So first thing we want to do in here is get an open space and right click and search for state machine. And you should see state machines, add new state machine. In this case, we're going to call this Locomotion. All right. Locomotion. Oh. And then we have our first state machine. All right. And double click on that state machine to get into the entry point. So it leaves you this first stub, which is entry. And so when we enter into Locomotion, we're going to add a new state, and we're going to call it idle, right? So first thing we'll have is an idle state. And then from idle, this one gets a little tricky here. When you get the cross arrows there, you can move. Otherwise, you want to get it when it's white like that, you can drag out and then add a new state. In this case, we're going to call this walk/run. So that'll be our walk run state. So again, our Locomotion state machine, oh, sorry. It gets tough to kind of grab these things. Like I said, if you go over it in white, you can drag stuff away. If you put the crosshairs in there, you can click and move it. When it's yellow, by the way, you can also move it. So our Locomotion state machine, the entry point is idle, and it goes to walk run. Well, walk run can also go back to idle. So this is two ways. So if you click here and you drag this back, you want to go back and forth. Now these are rules that are set up, and these are very simple. This will go back to the code in the event graph. So our entry point is idle, and we can go from idle to walk run. Those are the two places we can go in our Locomotion state machine. When you go from idle to walk run, I'm going to go ahead and set up the rules first. So idle to walk run, if you double click on this, right, you get a result, and you can enter this state. You can enter this state when should move, and we'll get should move is equal to true. So if should move is true, we enter this state. Now, conversely, in walk run, when we go back to idle, that's when we would add should not. Double click on that, should not move. So we'll drag our should move variable out, get should move. And you want to right click and look for math. And you're just going to do a simple Boolean, which is not. So should move not. If not should move, then we enter this state. And remember, it's pointing back. Enter what state? We enter idle state. So walk, run, the rule is go back when we should not move. We go to idle when we're idle, and should move is set to true. Go into the walk, run state. Now, what is the animations that we want for idle and walk, run? And this is where we're going to start to bring all this stuff over to the right here that are our animations in. So if I double click on idle, output animation pose, well, it's happy idle. So we bring happy idle over and we plug it in. Compile, save. I should have been doing this, by the way. Compile and save often, and check your errors down on the compiler results down here, so you're sure that you're not getting into any errors. So compile, save, compile, save. So that's our idle state. Our walk, run state, this is a little bit different, okay? We're gonna do this using our blend space, right? So we did the blend space Hooli down here. Remember, it shows up, it looks just like an animation because it's a series of animations, right? And so our blend space and the speed that we want for our blend space is our ground speed. So we're gonna get ground speed, plug that into speed, and plug that into the output animation pose. So compile and save often. Everything's green, that's all good. So let me rehash this real quick then. We went ahead and we created in our anim graph a locomotion state machine. In that state machine, we have an idle and a walk run state. And behind those are some animations that are gonna run. And idle, let's double click. Oh, idle, somehow went back. Anyway, go back into locomotion, go back, double click idle. There's our happy idle, we'll play for that. So there we have our first state machine. And this one, we're not gonna plug into the output pose yet. We're gonna do something in a little bit to do that. We're gonna use this locomotion though throughout. And so what you wanna do when you wanna reference a variable later is you can go ahead and drag this out and do, click on or search for pose. What you're looking for here is this new saved cache pose. I'm gonna call this locomotion as well. And let me just show you this in just a second. I'll do a mouse over this if I can get as big as I can. Hope you can read that. Denotes an animation tree that can be referenced elsewhere in the blueprint, which can be evaluated at most once per frame and then cached. So what we want to do is we want to make sure we can go and we can use this cached locomotion here. And we'll use that a bit in our main states as we also handle falling and jumping and everything. So we'll do that in the next video where we will plug all that then into the output pose, and we'll have a Hooli running around the screen in no time. So I'll compile and I'll save. This output pose is important just to kind of pound the point home here. Oh, let me go back here. I had my other Hooligan that I was playing with there. What you do, remember in our blueprints, we have our game mode. So in this case, I'll want to go and play with Hooli 4579, not that other Hooligan. So that's actually a good point. So remember, our game mode sets a default character that we want to play with. So I want to play with 4579. So now when I go in, I want to just be clear, since we haven't really plugged anything into that anim pose yet, we're still in this state of, stiff T-pose character, but we're really close. We've got some of the wiring behind it. And in the next video, what we'll do is we will jump into the rest of the state machines that we want to create. And we'll go ahead and we'll get them plugged into this output pose here. Again, see the note result was visible but ignored. We haven't plugged anything in or done anything. The good news is though, is we're compiling and our animation blueprint is happy for now. So I'll see you on the next video.